Hello and welcome to the second part of part 10 of making this space shooter in HTML and JavaScript. This video then, you remember from the last video, especially if you're following directly on, that we set up in defs.js the waypoints, and in enemy.js we loaded the sequences. This video here, there's going to be quite a lot of copy and paste, and the code is on GitHub because there's quite a bit to get through. And to be honest, I've been through it 3 or 4 times already, trying to find the best way to do it without going too fast but not going too slow. And I think the best way is really to do some copy and pasting. So I hope you don't mind about that. I like to type the code as well, as you know from a lot of the videos, but this is one of those where explanation is probably better than making loads of typing errors, which I always do. As a little bit of preparation here, I've already got waypoint.js added. It's a very simple class which has a constructor taking an x and a y, a direction x and a direction y, and in fact it completely mimics the waypoints that we have set up here, like this. One thing I thought for the future, which is why these are coded in like this, is probably they would be loaded in from a JSON file or something like that. But we've got a waypoint class to mimic that, which we'll use in the enemy class in this video. It takes XY, direction XY, makes a point where it is and then has its direction as well, and does nothing else, and will do for the rest of the series nothing else, but it's there to be added to if needed. The other thing that's been done is inside defs.js, some enemy states have been added on in the game settings, so ready, dead, and moving to a waypoint. And then in enemy.js itself, at the bottom, I removed the logging of the sequences to the console because it was annoying me. So we have to get started now then adding our enemy sprite. We've got the sequences and we now need to add our enemy sprite. And to do that, we're going to make a class called enemy, which extends sprite. And again, I'm going to copy and paste some code in here, otherwise this will last too long. And I'll try and explain it as best I can. I think that's the most important thing. So the constructor for the enemy looks like this. We have its div name. We've seen that with bullets and player before. It's got the asset description, has a reference to the game, to the player in the game board, which will be used later on. And most importantly of all here, well, not most importantly, but importantly, it has the particular sequence that it's been assigned. Hopefully you've understood how the sequences work from the previous video. So first thing we do is call the super. So we call the sprite constructor with all of the normal things there. The position is 0 by 0. Then we set the state, our enemy is ready to go, and then give it a list of a waypoint list. And in here we will load the waypoints from the sequence, but they'll be adjusted slightly, as we'll see in a minute. We have a target waypoint number that says which waypoint we are targeting. A target waypoint at the moment is just set 0, 0, 0, 0 because we're just making our enemy. The last waypoint index, this is actually set to the last index of the waypoints on the waypoint list, and this is just used to detect whether we've finished all of the waypoints or not. Maintain a link to the player, and then I've set the score, the lives, and the speed from the sequence here, and now a function that isn't defined yet called read in the waypoints and read in the waypoints from the sequence. So we're going to define now this read in waypoints function, and I'll try and describe why we've got a read in waypoints function. So the function itself is here taking in our waypoints list. First thing we do is empty our current waypoints list. When we've just created the enemy, there's no need to do that, but say we want to reassign a sequence or something, maybe doing something different in the game, then this is obviously useful. And now we're going to loop through every one of the waypoints in our list. I'm going to assign that waypoint to a temporary waypoint, t_wp, just a temporary variable. And I'm going to create a new waypoint using our waypoint class. And the thing that I'm going to do is, if you remember that in the sprite we make this anchor shift. So you remember we shift our position by minus the size width over 2 and minus the height width over 2 to get the center point of the position we want to specify in the middle of the sprite. That means our anchor shift values are negative. Well, I also want to shift the waypoint as well, so that the waypoint, so our sprite, the middle of our sprite sits over the waypoint. Otherwise everything's going to look slightly off. So to do this, I make a new waypoint object using the waypoint class, where I shift the waypoint that's from the waypoint list by the anchor shift x and y, so I shift the sprite properly. So it's going to use this waypoint to guide itself through the game screen. And once I've got that created, I then add it to the enemy's waypoint list, so it builds up its list of waypoints. The next function I want to add below this one is the set moving. So when the enemy is first created, it'll then be set moving by whatever's controlling it. And this set moving function hopefully is fairly clear to understand. The first target waypoint I'm looking at is number 0. It's the first waypoint on the waypoint list. I get this waypoint out of the list using my target waypoint number. The last waypoint index then, as I've explained, is the last waypoint on my list. So that's the length minus 1. And I'm going to set my enemy, its position, to the first waypoint on the list without using the shift. And now I'm going to add the enemy to the board at this waypoint position, again without using the shift. Now my next target waypoint number is 1, because I've used the target waypoint for 0 and set myself at that point. And I'll set the current target waypoint now to this particular one. And I'm going to set my state now as moving towards this particular waypoint. So I've used the first waypoint in the list simply to set my position, which is why in all of the definitions of the waypoints we see that actually the direction x and y are 0, 0 here. They're not needed. So now I've been set going, I need actually to be able to move towards a particular point. So I'm going to take in the function that does this, which is called move toward point. And again, this is on GitHub. You can copy and paste this in. It would take a little bit too much to type it all out or get very annoying watching me making mistakes. So move toward point takes a delta time, and this will come from update, just as with the bullets. We'll work out the increment that we can move, which is our speed multiplied by the time, and we'll increment our position accordingly for the by multiplying our increment by the direction x from our target waypoint and direction y. So remember, the first waypoint is used to set us where we are, but let's take this second waypoint here. We will calculate the inc, multiply 1 in the y and by 0 in the x direction. In other words, just move in the positive y direction down the screen. So we've incremented our position. The slightly tricky thing comes in knowing whether we've hit our waypoint or not. When we start doing this delta time times by speed, we can end up with positions being very, very specific to lots of decimal places. So I've got a little line here just saying if the absolute value, so the positive value of the delta, the difference between our x and the target waypoint x is less than the actual increment that we were going to move here, or the same with the y, then we'll force our position to be exactly the same as our target point, waypoint x and y. And now what we can do is we can ask ourselves, if our current point is equal to the target waypoint, then the enemy has reached the end of his waypoints, so we'll call kill me, which hasn't been done yet. But if he hasn't reached the end of his waypoint, then if our current position is equal to the target waypoint position, and we haven't written this function yet, it goes in the point class, I'm coming to that, I'll ask myself, I've reached my waypoint. And there are two possibilities. One is I'm at my last waypoint, so I'll ask, is my target waypoint number the same as the last index? If it is, then I'm going to kill myself. In other words, remove myself from the board, and here's some reached end code. Otherwise, I'm going to set my next waypoint, another function that we don't have. So let's add in the set next waypoint. It's very, very small, you'll be glad to know. All we do is increment our target waypoint number by 1 to move to the next one in the list, and then assign this target waypoint from the list. That's all we need to do. And then when we come round to move towards point next time, we'll automatically shift our direction as we need, increment our position, etc., etc. So 2 more functions need to be added before we go to the point class. One of them is the kill me. I put that in here, very similar to the bullet. State is now dead, and remove me please from the board. And last but not least, the update with the delta time. I'll take this log out that I had when I was just double checking it all earlier, where we basically say what's the state of our current, using a switch statement, what's the state of our enemy, and if he's moving, or she is moving towards a waypoint, then move it towards the point with the delta time that was passed into the update function. So that's quite a lot of code there, but it should be fairly straightforward. We're just taking a list of waypoints and going through each of the waypoints one at a time. Being shot by bullets and things we'll deal with later, but the main hard work has been done now, and I think this is probably the most involved bit of code in the whole series. Before I forget, I'm going to go to point and add in this equal to point function here, which just says are 2 points equal, is x equal to x, y equal to y, yes or no, return true or false. It's not really difficult to understand. And you'll remember with the bullets, if I just open the bullet.js, that we had the bullet class and we also had a bullet collection, which was something which sort of managed all of our bullets. We're going to do exactly the same thing then with the enemy and just define an enemy collection. So I'll drop this in here. And this is then a collection of enemies. So we have, much like, it's very, very similar to the bullets. We take the player as a reference. We have a list of enemies. The last added, so the time last added. This is a detection of whether the game is over. So in the game can be over in two ways. One, the player dies, or the other one is we finish all of the sequences and the player has reached the end of the game. Here we have current sequence index, and here we have an indication whether all the sequences have done. Now you may say, oh, well, then the game's over, isn't it? Well, you can have already gone through the last sequence, but the enemies are still on the screen. So we use this as part of the game over detection. Here's our count of our enemies to be able to get some unique divs, and then the reference to our player. First function I want to add in here, and again I'm going to copy paste because I'm really conscious of taking too long. It's better to explain. First one is on the class to just be able to kill all the enemies, which is a bit like the bullets, get rid of them all. So just go through all of the enemies and call the kill me function so they're removed from the board. And the next function then is the update function, which will be called from tick inside our main.js. So like the bullet, we add on our delta time. And now we check for something. If we haven't done all of our sequences and the delay before is less than the last added, then we'll add an enemy. Now what we need to do is update our enemies. And we're going to go reverse order through the list. I think I explained with the bullets about we're going to remove anything that's dead from the list. So therefore we have to go through the list in reverse order so that we don't get any funny indexing bugs or anything like that. So we're going to start with the last enemy on the list. If it states dead, then we'll remove it. Otherwise we'll update it. Now, you might think going through the last enemy on the list, we might get some slightly strange movement on the screen. And in fact, I did wonder this myself. It seems all right, but the other way to do it would be to go forwards through the list, record the indexes we need to move, and then do another loop going backwards through the list and removing the indexes as required after sorting that list of indexes of enemies to be removed. And the last thing we need to do then, once we've finished updating or removing our enemies, killing them, is then go and check whether the game is actually over, so we've managed to finish all of the sequences or not. So the check game over function itself looks like this. It's very, very simple. I've got a log to game over. I'll take that off for now. If the list of enemies is 0, and we've done all of our sequences, that means the enemies have either all been shot or they've all been removed from the board because they reached the end of their waypoints, and we've done all of the waypoints, then the game must be over. Very, very simple, and called at the end of each update. And last but not least, the last function in this file is the good old add a new enemy. So we get the sequence from this particular enemy. So the enemy collection, where are we? The enemy takes from the enemy sequences that we create. Remember, we created in the previous video. It creates, it takes that particular sequence. It then creates a new enemy, pushes that new enemy, and sets that new enemy then moving. Increases the count of enemies it's done, its sequence index, and then resets the last added time to 0. And now, if sequence index is equal to the length of all of our enemy sequences, then we know that we've done all of the sequences available, and we can set this then to true. So we should have everything we need then with our enemy collection and our enemies on the screen as well. I'm slightly hopeful that this will work. When we go into main, we need to set a couple of things up inside the main file though to get everything going. First of all, we're going to need a reset enemies function, just like we had for the reset bullets and the reset player. Ours is very simple in this case. We're just going to brutally make a new enemy collection taking in a reference to our player. And in reset game, just after reset bullets, I'm going to make a call to reset enemies before we actually get going. And that leaves us then purely with one thing to do, and that is in the tick is to update our enemies right after the bullets. And we should be, I say hesitantly, good to go. So I'll just refresh. And here we have an enemy, 2 enemies appearing on the screen and following their waypoints. And now we should get 6 enemies going up the screen. Indeed we have. And now we can see game over appearing down on the bottom right hand side of the screen. So that's pretty good then. A lot of code in there, but it really is. That was the biggest part of the whole of the game. And I hope that wasn't too hard to follow. If you get confused with the sequences, and I can always put another little video in, maybe just explaining on a couple of slides or something. But it should be fairly straightforward to understand. And yeah, onwards and upwards from here. So thanks very much for watching. I really appreciate the views and the comments and things. Feel free to leave one. And yeah, see you in the next video. Thanks very much.